In this video, I'd like to look back at these lens diagrams so that we can check your work, really. So I'm going to go through them individually. So each time we'll talk about drawing rays 1, 2, and 3. That refers to the naming system I used above in the original page. The pen I'm using is slightly thick. I'm going to draw ray 1 in red. So every time I do one of these diagrams, ray 1 on its way to the lens travels parallel to the principal axis. That's this horizontal line through the middle. Remember, this is perpendicular to what's called the optical axis, this vertical line through the lens. And because of how lenses are defined, after it hits the lens, it has to pass through the focal point on the other side. Second light ray I'm going to draw is going to start again at the light source, but this time it passes through what's called the optical center. Now this is a bit tricky sometimes to get just right with this ruler because it sort of snaps to set positions on the screen. So we're going to get as close as we can. I think 12 degrees is better than 10. We're slightly off, but we can live with that. Let's stick to red for this diagram. And second light ray there drawn on. So at this point, you've drawn two light rays that cross. Really, you've done enough to answer this question to say where the image forms. But kind of as a check, we usually draw the third light ray as well. Again, we've got a slight issue with the ruler snapping. But we want to start from the light source, pass through the principal focus on the near side. Now, this is the light ray that people often find a bit confusing because you kind of think to yourself, well, where did that one come from? Well, it comes from this principle called the reversibility of light. The lens works the same in both directions. So whereas the first one arrived at the lens parallel to the principal axis and then passed through the principal focus, this one at the bottom, you can imagine going the other way, is doing the same as what we've just said. It arrives parallel to the principal axis and goes through the principal focus. Now, it's not going that way, it's going the opposite way. But because light going left to right behaves the same as light going right to left, we know that that's what its behavior should be. So any light ray that arrives at the lens, having come through the principal focus, must travel parallel to the principal axis on the other side. So we said the other day that we were just going to label an image with an eye, and that's at that point where the light rays cross. If yours don't cross at a perfect point, it's not the end of the world. It's usually a result of our pen being sort of thick. Really, we should be doing this with a super sharp pencil on a piece of paper rather than with a thick pen line on a surface with this ruler that can't go to the exact position I want it to quite often. So for the second diagram, I've started drawing it already. We've got the first light ray that goes through parallel to the principal axis on its way to the lens, and then having gone through the having arrived at the optical axis, having arrived at the lens, it then goes through the principal focus or the focal point on the other side. So these points, the little crosses have got two names. We have to be a bit careful because I tend to switch between using the two. They're either called the focal point or the principal focus. Now, principal focus is a slightly difficult term because the point where these real light rays actually cross over one another is called the focus. So this point that I'm going to label with an I here, that is called the focus. This light source has its light rays focused at this one very specific point in space. However, the lens has these 2 points, one either side of it, called the principal focus, which is the place where light rays that arrive at the lens traveling parallel to the principal axis will be brought together. So the principal focus is different to the focus. The principal focus is also sometimes called the focal point, which is not a great naming convention, it has to be said, but that's what we go with. So that's that one. So similar, just kind of making the point that you can do it on either side. So this is the first one where something a bit peculiar happens. First light ray is fine, just about catches the edge of the lens, but in a minute we'll see that that doesn't really matter. Comes through the principal focus. Second light ray comes from the light source, goes through the optical center. And just to reiterate a point I've made previously, there is no guessing about where these light rays go. You never have a choice. There's never any judgment involved. I'm just going to extend that first one a bit. I suppose the judgment is how far you draw it, and the judgment I made wasn't very good because I didn't draw it far enough. There's never any judgment. Their positions are set in stone from the moment the diagram appears. Now, the third one has this peculiar feature that, having come through the principal focus, it gets to down here and it misses the lens. And you kind of think, well, yes, in reality, because it misses the lens, it carries on down this line and goes off into space. But we don't really care. We're not drawing the diagram to find out how much light is brought together at the focus. We're drawing the diagram to find out where the focus is. So what I've done here, and I've kind of done this in my head, what I should do really is draw the line on properly. What I've done is looked at the continuation of this optical axis going down, so beyond the edge of the lens, and when the light ray hits the optical axis, I've shown it going parallel to the principal axis on the right hand side, like we did in all the others, and you see it joins up. It didn't matter that it missed the lens. The lens is just a curve drawn on my diagram, so it doesn't matter if it misses the lens at all. The next one's even more extreme. I made the lens tiny on this one. Beyond that, it's pretty similar to our other ones. So when we come to draw, we don't care how big the lens is. The size of the lens does not matter for where the image forms. The size of the lens does matter. A bigger lens collects more light and therefore produces a brighter image. So the size of the lens does have an effect, but it doesn't affect where the image is. And all we're using these diagrams for is to work out where the image forms, not how bright the image is. So this diagram, it's definitely true to say the image would be pretty dim on, because there's only a small number of light rays that start at the light source and actually pass through the lens to reach this point where the rays cross over with one another. There's very few light rays that do that compared to the larger lenses that we've had in the previous examples, but that doesn't matter. The image still forms in the same place, even if there's not many light rays getting there. So if I had a screen set up, I'd expect to see a dim image over at this point, whereas in my previous one, image is in almost exactly the same place, but this one would be brighter because the lens has collected a lot more light and sent it through to this position. Last one I gave you had 3 light sources, and this was to kind of make a point. I've got light source 1, 2, and it was meant to be 3. I've labeled it as 1, 2, and 1. In this diagram, draw 3 sets of principal rays, one of each color, label the images I1, I2, and I3. We're only ever going to do this once because it illustrates an important point that we're going to make use of in the rest of today's lesson. So I'm going to do it for each one. Pardon me. Now, once again, we can draw 3 for each. I've not drawn that first one far enough, have I? Let's correct that now. So again, the ruler's in pretty much the right place. Sometimes because it snaps to whole angles, it doesn't quite go where I want it to, but we can get close enough. That one's not great. I really want it at 17.5 there. That's a bit annoying. It's probably a better solution, but it'll do for now. Third one, so here, through the principal focus on the way in, arrives at the lens having come through the principal focus. So on the other side, it will travel parallel to the principal axis. So on the last couple of diagrams, we've had this thing where they don't quite meet at a single point in space. That's fine. It's usually a result of either our lines are a bit thick and therefore we've got things in the wrong place, or the 2 focal points aren't at exactly the same distance from the lens. If either of those things is true, then you don't get the light rays meeting at a perfect point in space, but it's usually because of thickness of pens. So these pens are quite thick, but show up nicely, so you know there's a bit of a compromise. So again, I'm drawing these light rays in, no choice about where they go. I'm not choosing their positions. I kind of like to think that these light rays already exist. It's just no one's drawn them yet. They have to be in these particular positions. I don't get to choose where any of these light rays go. They are the principal light rays, and therefore they've always existed in these set positions. We just couldn't see them before. So that's the red ones. Let's mark in. Oh, sorry, I didn't mean to move that. I2. That's an I. And then the green ones last of all. Sorry, I've moved it off the screen slightly. one, and one through the optical center. Two, one through the nearer principal focus. And then parallel to the principal axis on the right hand side gives us, in fact these green ones aren't meeting up very nicely at all, are they? There we are. We've got quite a big triangle there, so we're going to label it right here in the middle of the triangle. So that's I3. We've got I2 and we've got I1. Now, this last diagram is useful. I'm not going to draw all the arrows on because it's messy enough already. What we notice on the last diagram is an important feature for lenses, which is that they have a plane of focus. The three light sources, 1, 2, and 3, are at the same distance from the lens, the same horizontal distance from the lens. They're all different distances from the optical center, but the distance between those two black lines is the same as you go up and down all heights. So we say the three objects are at the same distance from the lens. And what we notice, well, it doesn't come out perfectly, but approximately the three images are also at the same distance from the lens. This is called the object distance. And this is called the image distance. So this is a useful rule going forwards, because if ever we have an object where all parts of it are at the same distance from the lens, we don't really need to do it for more than one point. In future, what we're going to say, I'm going to rub out these three black lines, is if there is an object that has some height, let's draw it in, a nice thick black arrow, like this. So this is our kind of standard representation of an object. We draw it as an arrow to kind of signify that it's got a very clear top, but we also show usually that it extends back to the optical axis. What we could do without drawing the red and the greens, so are they easy enough to take off? Yeah, I think I can if I do that. Even if I never drew any of those red or green light rays, I would be able to get to here and say the image appears like this. So this is a really useful shortcut to knowing where an image appears, because once we found the position of one point, we know the whole object sits in the same plane, or we sometimes call it the plane of focus of the lens.